Sample Domain 3 question. A solutions architect needs to improve the performance of a company's critical data processing application. The application currently uses a single large Amazon RDS instance. Which of the following would most effectively enhance the application's performance? So our goal here very clearly is performance enhancement. We're trying to make our application run faster and be more responsive. One important clue in this question is that we are using a data processing application. We're doing a lot of work updating or querying data, and it's important that that database give us the best performance that it can. Our first option is to switch to a larger instance type for the Amazon RDS instance. RDS creates database servers that run inside the context of an Amazon EC2 virtual machine. So one way to improve performance might be to use a larger instance type. The addition of more CPU power and more memory, that could help. So that's at least a possibility. One downside to consider is the additional costs that come with a larger EC2 instance. A second option is to implement Amazon Elasticache to cache frequent database queries. Now that's a very intriguing idea. Databases that receive a lot of repeated query traffic where the same question gets asked again and again often will benefit from a cache, a set of data stored off to the side of the database server that allows for rapid answering of recently asked questions. So that certainly could enhance our application's performance. Should we consider using Amazon Redshift instead of RDS? Well, no, that's a data warehouse. If I'm not trying to support a live application, but I've got a need to do data analytics on the last 10 years of company history to spot trends, now a data warehouse like Redshift becomes useful to me. But in this case, that is not a strategy for improving the performance of this application. Our last option is to enable multi-availability zone deployment for the RDS instance. That would deploy 2 database servers, one in each of 2 different availability zones. That is in many cases a good best practice. That gives us a very resilient architecture, but it doesn't improve the performance of this architecture. It just makes it more resilient in the face of the failure of a database server. So I think we'll have to say no on that one as well. So we return to reevaluating our first 2 options, larger instance type or turn on Elasticache. Our goal is to figure out which one would most effectively enhance performance. Both probably would be helpful, but we will probably see a more immediate impact from turning on caching. Moving to a larger instance type may improve our performance marginally, but again, there are significant costs there. Turning on caching will instantly allow us to offload a lot of read activity from the database server onto the cache, freeing up the database server to be much more effective in its primary task of writing data into storage. So implementing Elasticache will be our most effective performance-enhancing technique here.